All right, so 3.8, this is the last section, graphing piecewise functions. Piecewise just means that they're in pieces, okay? That means that there's going to be two halves of lines on the graph instead of a full line, okay? So instead of it looking like this across the graph, it might look like this. Okay, so it's just cut into two pieces. But you're just graphing two separate lines using tables, okay? And then the last thing is shifting and reflecting graphs. This is the big part, okay? This is the part where we'll constantly go back to it, so there's a decent amount of it on the test. There's probably 4 or 5 problems based on shifting graphs. And so I say that every year. There are about 4 or 5 problems on shifting graphs. So that means if you don't know how to shift graphs, it really hurts your grade. Okay, so look that over, make sure you know that before the test. All right, so this is a piecewise function. So it's a function, and then it's got two pieces. This piece has its y equals mx plus b. This piece has its y equals mx plus b. And then it has this that tells you where it goes, and we'll explain that a little more later. But first, let me explain why we have piecewise functions. Because sometimes some of the information you have applies to this line and some applies to this line. So if we're trying to solve for f of 2, if we're trying to plug 2 in, which we did last class, we need to figure out which one of these are we allowed to plug 2 into. If 2 is x, which one of these is 2 allowed to be x? Top one or the bottom one? X is greater than 0. So yes, it has to plug into this. It can't plug into this because 2 is not less than 0. Okay, so these are the parameters to tell you which one to use. So because we're using 2, and that's greater than 0, we have to use the bottom. So for f of 2, yeah.
What if it's a negative x though?
Yeah, it's negative 1 for x.
Uh,
That's not greater than...
Are you talking about in, like right here, because it says negative x?
Yeah.
We are only talking about that number, whatever that number
Oh,
is.
sorry.
That number is what you're going to plug into this. So this just runs off of that number.
Oh.
Okay, so that is negative 2 minus 1. So we know f of 2 equals negative 3. Okay, now we're going to look at the next one. It says f of negative 6. Negative 6, does that apply to less than 0 or greater than 0? Less than 0, so we have to use this top one. Okay, so you're just using whichever one is allowed to use it. So f of negative 6 equals 2 parentheses negative 6 plus 3. So 2 times negative 6 is negative 12 plus 3 is a negative 9. Okay, last one. Where does 0 plug in? Both of them have the number 0, but which one? Top or bottom? Bottom.
Top because it's greater than or equal to.
Because of that line right there. So even though this number 0 is down here, it says it has to be greater than 0. It cannot be equal. So up here we have to use 0. Okay, so that is f of 0 equals 2 times 0 plus 3. So f of 0 equals 3. So that's how we would use piecewise functions. Now we're going to talk about how to graph them. Okay? So you can always check your work using y equals mx plus b, because that is y equals mx plus b and y equals mx plus b. But how we're going to graph piecewise functions is always going to be the same way, and this is what your Edmodo homework is going to be over. Okay? So graphing piecewise functions. You're going to create 2 tables, and actually I have created those for you. I'll show them. I'll show you them. But you're going to create 2 tables. We're going to fill these tables out very specifically. Okay? So first, this top table, I'm going to do that in blue. That top table, I'm going to write down everything I know about the top line. Okay, that top line, f of x equals 2x plus 3. Okay, so we're just looking at this top line. What else do I know about this top line? This. X is what? So we're going to write that above this x. X is less than or equal to 0. Okay, and what do we do with lines that have a equals underneath when we graph them? What does that equal usually mean when we graph lines?
Solid.
Solid, or in this case, if we're graphing a specific point, it would be a closed circle, right? So it would be a solid line or a closed circle. Solid line that's when we're shading the whole thing. But in this case, that just means a closed circle. So next to it, I'm just going to put a closed dot, just to remind me later. Okay, so that's all this information just written down right there on that top line. Okay? Now we need to come up with some stuff. We usually fill out the x's first, so we're going to fill out these x's. The main rule is we always start with this number on both tables, no matter what. Even though this one does not say equal to, start at this number. So our first number on our x's is 0. And our second number and third, but I'm actually only going to make you do 2 numbers, so we don't even have to think about this bottom line, because you only need 2 numbers to create a line, or 2 points to create a line. So this is why we wrote this down. What am I allowed to use right here? It says x is less than 0. So I have to use a -1. I can't use anything bigger, because that's not allowed on this line. So this is a -1. Okay, so let's plug those 2 things in to figure out our points. So if I plug in a 0 on that first one, I get a 3, because it's 2 times 0 plus 3. And then 2 times -1 plus 3 is what? 1. Okay, last thing for your line is you start at the top point. We start here on a filled in dot, and then we go towards the second point. Okay, so 0 over 0 up 3. This is where we're going to start, and I'm going to fill that dot in, and then we're going to go towards the second point. That second point is at -1, 1. So -1, 1. Here's my second point. We're going to start at the first and go through the second. Okay, so this is different than our other lines, because our other lines went the entire graph. This one stops here because it's a piece of a function. Okay, the first one's always the hardest. Let's do the second side. Let's do the bottom half exactly the same way. Okay, so let's fill out every piece of information we know about that bottom line. So we know f of x is -x minus 1. We know our domain is what it's called, is x is greater than 0. And then we know that is an open circle. Because it does not say equal to here. And then every table is going to start with the number that's in your problem. So it's going to start with a 0, even though it does not say equal 0. And then what other x's can I plug in? Let's ignore that bottom line. What other x am I allowed to plug in on this one?
1.
A 1. Okay? And we can plug in the easiest number. So if it says stuff greater than 2, you don't have to put 3. You can put 5 if you want. You can put something easier. Okay? So there's a 1 here. Then plug that in. So -0 minus 1. -0 minus 1 is -1. That's our starting point. So over 0 down 1. Put an open circle on that. And then plug in a 1. -1 minus 1. That's a -2. So over 1 down 2. There's my second point. Only our first point is open. This is just where the line is going to go through. So we're going to start at the first and go towards the second. That should be connected. And that's how you graph piecewise functions. Okay? So it is a bit of a process, but I've done everything I can. I'll show you. Let me see if I've got it right here. I've made those for you. So all you have to do is just fill in your numbers and put it on the graph. Okay? All right. So let's try the next one. Yeah. Go ahead and try the next one for me. So fill out every bit of information for the top of that thing. Always follow your domain. Always follow this to get your other x. We good? Yeah. I couldn't remember who said it. Yeah.
So it's always one, it's always 0 positive 1 for x, and always 0 negative 1 for the first one.
So it always starts at whatever number's here. This number just depends on where we're going. So this number could be a 2, and then it would be something less than a 2 and greater than 2. It always starts at that number, and then wherever you go from there. So it might not always be 0, 1, 0, negative 1. It all depends on what this part says. So that says the x's on this top one are only allowed to be less than 0. But if that top one said greater than 0, then you'd have to put 0, 1. Does that make sense?
Yeah.
Okay. So 0, less than or equal to 0. Did I forget to erase that one? Draw it. Or did I just write that in? Is this already written down in yours? Yeah, so I just forgot to erase it. Okay. And that bottom one is an open circle. Again, we don't need 3 points, so you don't have to do a third point. So this one goes off the graph a little bit, if you haven't seen it yet. Hopefully you got to this point. It did go off the graph a little bit, so it didn't have to be exact. But I tried to make it pretty close. Again, it starts at this number no matter what this number is. Okay? So sometimes that's 2s, sometimes those actually might be different sometimes. Okay? If they're different, you just start your table which one is attached to you. So if this was a 2, you put a 2 here. If this one was a 3, you put a 3 here. So it just depends on what is next to your individual equation. Okay? So that's piecewise functions. We can do a little more if we need to, but you're going to have a lot of homework over it to get that solidified in your head. On the test, there will be a couple of those you have to do on your own. Okay? I took this off of my math lab because my math lab actually made it weirder because they made it multiple choice. And so it was hard to read the little graphs and stuff. So I like this better. I did say you could check this using y equals mx plus b. This one is y equals m. So your m is negative 2 over 1. And then your b is 0. So this should start at 0. And then it should go down to over 1, that line would go through that point, so that's good. Okay, so you can check them that way. Our intercept is 4, and then it should go up 2 over 1, so at 4, up 2 over 1, so that one's good too. And then this just tells you on the x-axis less than 0. So according to this x-axis, it starts at 0 and everything less than 0. This is x is greater than 0, so it starts at 0 and everything greater than 0. So you can check it using that, but I want you to solve it using the tables. They're the most precise way to do it. Okay, last thing is these shifts. Okay, these shifts, it's just moving these specific graphs around. These are graphs that are common, ones that you should see the equation and know what shape it's going to make. Okay, first is the function of x, y equals x. That is what we've been working with the whole time. It's just a straight line. Okay, up next, I've mentioned it a couple times, x squared makes a U shape. That's called a quadratic. That is something that will come up a lot more. Down here is the square root. A square root makes a square root sign or close to it. So you can see that it starts at the middle and it does basically what this square root symbol does. Okay, it makes that pretty much that same shape without that tail on it. Last one is something called absolute value, which we've talked about already. Absolute value, if we write that down, absolute value, people remember absolute value is shaped like a V, just like in that word value. Okay, another way people remember square root. Square root is if you use a lowercase r, it looks like that lowercase r. That's the other way. Okay? I think it's easier just to remember it looks like this symbol. All right, so those are common graphs. Okay, so those are common graphs. Tell me something, even though these are all different, tell me something they have in common with each other. Yeah.
They all go above the x-axis.
They all go above the x-axis, but this one goes below as well. What else? What's another thing that they have in common? Yeah?
Well, they're all
Yeah, they're all functions, and they all go on forever. But what part of the graph do all of them touch? That's the main thing.
The center.
The center, the origin. Okay, they all go through the origin. There will be some that don't do that, but right now we're only talking about these. So they all go through the origin. So when we're shifting them, when we're moving them, we're always going to move them according to their starting point, and they all start at the middle. So if we put y equals mx plus b here, if there was a plus b, this would not start at the middle, it would start up or down on the y-axis. Okay? So if we added something to it, that's going to make it move around. So if we look at this one, it says to graph both of these, so we're going to graph the top one first. The top one is m equals 3 over 1, and b is 0, 0. So 0, 0, up 3 over 1. Okay, up 3 over 1, there's our first graph right there. And then our second one is the same slope, but a different y-intercept. So that means they're going to be parallel because they have the same slope. So 3 over 1. B is 0, 5. So we're going to start at 5 and then still go up 3 over 1. Guess that'll work. No, it won't. What is going on? Okay, so there's our second line. So what happened between these is this dot, this origin, went up 5. Okay, it went up 5. And the reason it went up 5 is because we put a plus 5 on the outside. Okay, so what that shows us is that if anything's added or subtracted onto the outside, that moves it up or down, because that's just a y-intercept, and that's what we've been working with the whole time. Okay, so, yeah. So let me write that right below this, right here. So if it is outside is how I will normally say it. If it is outside, it moves up or down and I'm going to use the word regular, and I'm going to explain why I use the word regular in just a second. Okay, and we also know that that's just a y-intercept. That's our b. That's what we always move up or down. And remember, this is that part on the test that's really, really heavy. This is going to be a big part of the test. The next thing is just horizontal shifts. Okay, so that was vertical shifts. That goes up and down. Horizontal shifts move left and right. Okay, obviously that's what a horizon is. It goes left and right. Okay, so the reason I use the word outside is because this inside, this connected stuff, is what moves it left to right. So connected would look something like this, maybe. Okay, or connected would look something like this, x minus 2. It's connected to it. It's inside of something else. The other way you'll see it a lot is this, x minus 2 squared. So all those are obviously connected to the x. If it's connected to the x, it moves it left and right. Okay, so up here, right, connected. To x goes left and right. And that goes back to that word regular that I used.
Okay, send your homework. It's Karen.
Your homework that's due tomorrow? Or why I chose that word regular up here. I said up and down and regular. Okay? Well, if we look at this, what happened to our graph? The blue was our original. We moved it to the right 2. But up here it says negative 2. It says minus 2. So we're going to move it opposite of what you would think. Instead of to the negative 2, we went to the right 2. So that's why the first one says regular, is because you're just going to move it exactly how you think. But if it's connected to the x, you have to move it left and right, but opposite of what you would think. Okay? So because that says x minus 2, we're actually going to go towards the positive 2. Or right 2. Okay, that is where a lot of people get confused by this. You're just going to go to the opposite of what's there when it's connected. So it says negative 2, we're going to go to the positive 2. It says negative 2, we're moving to the positive 2 from our original location. And that's only when it's connected. Okay, that says that right here, but it says it in a bunch more letters, so it's not very helpful. That's why I don't like the way that the book says it. So let's jump to these real quick. Okay, this first one, square root. So what shape is it?
The little R, yeah.
The R, right? The one that looks like the square root symbol. So it's going to look like this, starting at the middle, because all of them start at the middle. Okay, now, is that 5 connected to the x or not connected? Is it grouped with it?
No.
Yes. Maybe.
Looks like it is.
Yeah.
It's underneath this. It's all
Yeah,
underneath
it
this,
is.
right?
It is.
So it is grouped with it. Because there could be something outside like this. That's what I mean. Okay? So that is grouped with it. So we're going to move that left and right. So we're going to move that left and right, but opposite. So instead of going to the positive 5, we're going to go to the negative 5 with that. So we're going to take this and move it. I don't know why that won't move today. Move that to the negative 5. Okay, does that make sense? Just moving left and right or up and down. You just got to know which one moves which way. Okay, what about the red one? The red one, what shape is that red one? It's a U, because this squared makes it a U. It's a quadratic. So it's a U shape. It goes through the middle, just like all of them. It doesn't have to be perfect. Okay, now tell me, is that 5 attached to the x or not attached to the x? Not attached. So if it's not attached, it's just like a y-intercept that you've been doing the entire year. So that's going to go regular up 5. God, why won't that work? I can't drag anything. So up 5. And again, that is going up regular 5.
Oh my goodness.
Okay?
How do you know what shape it is?
Based on
Wait,
the,
wait.
Yeah.
Do we even have to like draw like the zeros? Like, do we have to start with the zeros?
No.
We can just draw it where.
Okay? What about the purple? The purple has 2 different things. I always tell you to start with the outside. Okay, so what is the outside thing telling us to do? Negative 3. It's outside, so that's up and down, and it's regular. So that's going to move down 3. Okay, so this is a U shape because it says squared. Okay, that moves down 3. Why I want this bark. Down 3. And then what does the inside tell us to do? Well, it says negative 4, but when it's inside, it's opposite, right? So that's going to move to the right 4. So we're going to take that and move it down 3 and then to the right 4. So that's where your graph should end up. Okay, last one, that green. What shape is that green? Okay, it's a V, and it goes through the center. Okay, then that V is moving down 5, because this is a y-intercept, down 5, and which direction, left or right? Right, because it's opposite 1. So we're going to go to the positive 1 because it says minus 1 in there. So down 5, right 1. There's our answer. Yeah.
But what if it says its absolute value does not mean
Doesn't matter.
it?
Doesn't matter. That matters when you're plugging stuff in to solve it. But right here, doesn't matter. That's still a minus inside. Because it's just your symbol. Okay? But yes, that's good to think. But that all happens when you're actually solving the inside. Okay? The absolute value does not change that symbol. It changes when that's actually solved. Okay? On these problems, because these are multiple choices on your test and on your homework, on these problems, another way that you could do it, if you forget, because some people just get stressed out and forget which ones move left and right and up and down. They just do. If that ever happens, just make a small table and plug in a couple X's. See which ones end up on your graph. Right? Plug in a 0 and a 1. They should end up in a specific place. If you plug in a 0 here, it should be on 5. If it's not on 5, if it's down here, then you know you did something wrong. So you can always plug stuff in. I just think it's easier if you know these 2 things. Okay, so up and down is just your y-intercept. We've been working with that all year. Left and right is opposite when it's connected. Okay? We skipped over this page. This is reflections. Reflections are when you make the opposite letter negative. So if I want a reflection over the x-axis, all I have to do is make the y negative. Okay, the y is the same as f of x. So you can see right here, it says that. In order to flip it, we just make the entire thing negative, the f of x negative. In order to flip it across the y-axis, or y-axis reflection, this way, we just change our opposite letter. That won't come up as much, and when it does, we'll talk about it a lot more. But right now, I just want to give you all a little bit of time to work on those piecewise functions. All right, any side you need me to go back to? We good?